The F distribution. Here we have a picture of two different F curves. One F curve has degrees of freedom of 9, 50 and has a much higher peak than the curve with degrees of freedom of 10, 2. F curves are right skewed, very similar to chi-squared curves. Basic properties of F curves. Property 1. The total area under an F curve equals 1. Property 2. An F curve starts at 0 on the horizontal axis and extends indefinitely to the right, approaching but never touching the horizontal axis as it does so. Property 3. An F curve is right skewed. Assumptions, conditions for one-way ANOVA. 1. Simple random samples. The sample taken from the populations under consideration are simple random samples. 2. Independent samples. The sample taken from the populations under consideration are independent of one another. 3. Normal populations. For each population, the variable under consideration is normally distributed. 4. Equal standard deviations. The standard deviations of the variable under consideration are the same for all populations. Process for comparing four population means. So we have population 1, households in the Northeast. We take a sample of that population. We compute the sample mean, x bar sub 1. Then we take a population 2, households in the Midwest. We take a sample from population 2, compute the sample mean, x bar sub 2, then take population 3, households in the South, take a sample from that population, compute the mean, x bar sub 3, population 4, households in the West, which we take sample from that population, and compute the sample mean, x bar sub 4. Then we take our four sample means, compare x bar sub 1, x bar sub 2, x bar sub 3, x bar sub 4, and make a decision. That's why we're going to use our F value, since we are comparing several samples from several populations. Distribution of the F statistic for one-way ANOVA. Suppose that each variable under consideration is normally distributed on each of k populations, and that the population standard deviations are equal. Then, for independent samples for the k populations, the variable f equals MSTR divided by MSE has the F distribution with degrees of freedom k-1 and n-k if the null hypothesis of each population mean is true. Here, n denotes the total number of observations. Example, suppose that a one-way ANOVA is being performed to compare the mean of 5 populations, and that the sample sizes are 11, 15, 18, 16, and 15. Determine the degrees of freedom for the F statistic. So in order to use the table for the F statistic, we need to know the degrees of freedom. To find the degrees of freedom, we want to use k-1 and then n-k. So we're going to have two numbers that we will use. In order to find the degrees of freedom, we need to know k and n. We have 5 samples. Sample of size 11, a sample of size 15, a sample of size 18, a sample of size 16, and a sample of size 15. So k is 5. For n, we want to know how many samples total were taken. So to find n, I need 11 plus 15 plus 18 plus 16 plus 15, and that gives us 75. So for our degrees of freedom, our first number is 5 minus 1, and our second number is 75 minus 5. So our degrees of freedom are 4, 70, and we write those in parentheses. One-way ANOVA test. Purpose: to perform a hypothesis test to compare k population means, mu sub 1, mu sub 2, up to mu sub k, depending on how many populations you have. Assumptions. 1. Simple random samples. 2. Independent samples. 3. Normal populations. 4. Equal population standard deviations. One-way ANOVA test. Step 1. The null hypothesis and the alternative hypothesis are, respectively, H sub 0 colon mu sub 1 equals mu sub 2 equals mu sub k. H sub a, not all the means are equal. Step 2. Decide on the significance level alpha. Step 3. Compute the value of the test statistic f equals MSTR divided by MSE and denote that value f sub 0. To do so, construct a one-way ANOVA table where we have our source, degrees of freedom, sample size, MS, which equals SS divided by DF, F statistic. The treatment, K-1 for my degrees of freedom, SS is SSTR, MS is MSTR equals SSTR divided by K-1, and our F statistic, F equals MSTR divided by MSE. Our error, N minus K degrees of freedom, our SS is SSE, MS is MSE equals SSE divided by N minus K, our total is N minus 1, and our SS is SST. We are going to use our calculator to find F so we won't have to construct this table. Step 4. The critical value is F sub alpha with degrees of freedom K-1 and N minus K. Use the values F sub alpha to find the critical value. So our rejection region is the area to the left of F sub alpha. Our rejection region is the area to the right of F sub alpha, and our do not reject region is the area to the left. Step 5. If the value of the test statistic falls in the rejection region, reject H sub 0. Otherwise, do not reject H sub 0. Step 6. Interpret the results of the hypothesis test. One-way ANOVA test using p-value approach. Step 4. The F statistic has degrees of freedom K-1 and N minus K. Use the values of F sub alpha to estimate the p-value or obtain it exactly by using technology. The p-value is the area to the left of F sub 0, our test statistic. Step 5. If p is less than or equal to alpha, reject H sub 0. Otherwise, do not reject H sub 0. Step 6. Interpret the results of the hypothesis test. Example using critical values. To see how much difference time of day made on the speed at which he could download files, a college sophomore placed a file on a remote server, then proceeded to download it at 3 different time periods of the day. He downloaded the file 18 times in all, 6 times at each time of day, and recorded the time in seconds that the download took. At the 5% significance level, do the data provide sufficient evidence to conclude that a difference exists in the mean download speed? Early was at 7 a.m. We have 62 seconds, 160 seconds, 94 seconds, 220 seconds, 118 seconds, 78 seconds. Evening was at 5 p.m., 207 seconds, 301 seconds, 252 seconds, 339 seconds, 238 seconds, 202 seconds. Late night was at 12 a.m., which was 219 seconds, 180 seconds, 183 seconds, 221 seconds, 202 seconds, 162 seconds. What are the correct hypotheses for a one-way ANOVA test? So we have the sketch of what our F score would look like with our rejection region and our do not reject region. Let mu sub 1, mu sub 2, and mu sub 3 be the population times for 7 a.m., 5 p.m., and 12 a.m. respectively. Step 1, we want to find h sub 0 and h sub a. For a one-way ANOVA test, our means are equal. H sub 0 is mu sub 1 equals mu sub 2 equals mu sub 3. And h sub a, not all the means are equal. Step 2, decide on the significance level alpha. Alpha is 0.05. What is the test statistic? Step 3, compute the value of the test statistic and denote the value f sub 0. To do this, we want to use our calculator. So we go to Stat, Edit. Under L1, we want to type our 7 a.m. data. 62, 160, 94, 220, 118, 78. Under L2, we want to type the 5 p.m. data. 207, 301, 252, 339, 238, 202, and then under L3 we want to type our late night data. 219, 180, 183, 221, 202, and 162. Then I notice when double checking my data that I have a couple of errors. One of them is the first data point under L3. So I'm going to retype 219. And then my second error is under L2, 339. Now I'm ready to find F. Stat, go over to Tests, go to the very bottom, up arrow, and H is ANOVA. Press Enter. Well, now I need to type in the list where I've recorded the data. Second 1 for L1, comma, second 2 for L2, comma, second 3 for L3. Close my parentheses. Enter. F equals 11.75, and I want to use 2 decimal places. The test statistic is F equals 11.75. Determine the critical value. Step 4. The critical value is F sub alpha with degrees of freedom k-1 and n-k. Use the values of F sub alpha to find the critical value. So first we want to find our degrees of freedom. If we go back to the calculator, the degrees of freedom for my factor are 2. I have 3 means, and 3 minus 1 is 2. The degrees of freedom for my error is 15. My n is 18, and k is 3, so 18 minus 3 is 15. So now I want to find my critical value. So going to my table, my first degree of freedom was 2, so I want the column with 2. My second degree of freedom was 15, so I want the row with 15. Next, I need to find alpha, which was 0.05. So my value is 3.68. The critical value is F sub alpha equals 3.68. Step 5. If the value of the test statistic falls in the rejection region, reject H sub 0. Otherwise, do not reject H sub 0. So I want to plot my critical value and my test statistic on my drawing, and my critical value is 3.68 and F which is 11.75, is to the right of that. Reject H0, the null hypothesis. Step 6. Interpret the results of the hypothesis test. The data provide sufficient evidence to conclude that the population means are not the same. Example using p-values. 5 strains of bacteria were observed for 24 hours. The table given to the right reports bacteria counts in millions for different cases from each of the 5 strains. Some summary statistics for these data are given below. At the 5% significance level, do the data provide sufficient evidence to conclude that a difference exists in mean bacteria counts among the 5 strains? We have T1 equals 102, T2 equals 125, T3 equals 186, T4 equals 95, T5 equals 194, and the sum of x sub I squared equals 23,550. Our data set for strain A, I have 13, 28, 17, 13, 31. For strain B, I have 31, 15, 29, 34, 16. For strain C, I have 46, 45, 31, 15, 49. For strain D, I have 16, 15, 14, 20, 30. For strain E, I have 31, 48, 44, 48, 23. Continuing with our example, what are the correct hypotheses for a one-way ANOVA test? So we have our F curve with the p-value shaded to the right of f sub 0. Let mu sub 1, mu sub 2, mu sub 3, mu sub 4, and mu sub 5 be the population means for strains A, B, C, D, and E, respectively. Step 1. Find H sub 0 and H sub A. H sub 0 is mu sub 1 equals mu sub 2 equals mu sub 3 equals mu sub 4 equals mu sub 5. H sub A, not all the means are equal. Step 2. Decide on the significance level alpha. We were told in the original problem that alpha is 0.05. Continuing, what is the test statistic? Step 3. Compute the value of the test statistic and denote that value f sub 0. So we want to go to our calculator to find this. Stat, edit, we type the data for A under L1. 13, 28, 17, 13, 31. Moving over to L2, we type our data for B. 31, 15, 29, 34, 16. Then we move over to L3 for our data for C. 46, 45, 31, 15, 49. Moving to L4, we type our data for D. 16, 15, 14, 20, 30. Then in L5 we type our data for E. 31, 48, 44, 48, 23. Now we are ready to go to Stat, over to Test, and we want the ANOVA test. Enter. And we want to use L1, comma, L2, comma, L3, comma, L4, comma, and L5. Enter. And we have our F statistic for 0.169. Rounding to 2 decimal places, the test statistic is F equals 4.17. Continuing, determine the p-value. Step 4, the F statistic has degrees of freedom k-1 and n-k. Use the values of F sub alpha to estimate the p-value or obtain it exactly by using technology. We've done our calculations for F, so heading back to our calculator, we see that our p-value is 0.012896. Rounding that to 3 decimal places, the p-value is 0.013. Continuing with our example, step 5. If p is less than or equal to alpha, reject h sub 0. Otherwise, do not reject h sub 0. Since p is 0.013 and alpha is 0.05, 0.013 is less than or equal to 0.05. The p-value is less than 0.05. Reject h sub 0, the null hypothesis. Step 6. Interpret the results of the hypothesis test. The data provide sufficient evidence to conclude that the population means are not all the same. To recap the section, the F distribution, basic property of F curves. The total area under an F curve equals 1. The F curve starts at 0 on the horizontal axis and extends indefinitely to the right, approaching but never touching the horizontal axis. And F curve is right skewed. Assumptions for one-way ANOVA. Assumptions: 1. Simple random sample. 2. Independent sample. 3. Normal populations. 4. Equal standard deviations.